about specific heat real quick. All right, what does specific heat tell us? Okay, now we talked about specific heat the other day, and we learned to calculate specific heat, but I didn't talk about what it told us. Okay, and you did a couple homework problems last night, and you can calculate it, and I'll give you those answers in just a second. But again, you can talk about what it means. So, what does specific heat tell us? Well, if I write down water specific heat, water has a specific heat of 4.184 joules over grams degrees Celsius. Aluminum has one of 0.897 joules over grams degrees Celsius. Iron is 0.449. And copper is 0.385. Remember all these useful numbers. I can't remember to talk about why. All right. So what do these numbers mean, or what do these numbers tell us? Right? They're important for significance. Well, this number is a very large specific heat. And these numbers are very small specific heat. All right? Now, if you think about two things y'all are all familiar with, I'm going to talk about water and aluminum. All right? Everybody in here, I hope, has played with aluminum foil and water in terms of cooking. Now, when I asked Second Judy about this, I don't think they played with it all that much based on the answers they gave me. Because I talked about cooking with foil, and they had no idea. If any of y'all cooked with aluminum foil before, okay, so y'all have. All right, I'm of the lazy bride. Okay, I'm stupid reason I got married in that show. So they expect me to cook at night. So anyhow, I don't like to scrub pots and pans a whole lot, so I put down what on the pan. Aluminum foil. Either yank stuff off the trash, but I do actually wash the thing is on, so I just want you to clean. So anyhow, when I need to pull the foil off, once it comes out of the oven, if I wrap bread in there, wrap it on a pan, or my children are incredibly weird. They don't like grill marks on their meat. Okay? If y'all grill outside, toast, steaks, burgers, chicken, pork, then I'm on the grill marks. Well, I put what on my grill every time I go outside the grill? I'm going to foil. Put the grill or foil down, put it in the wrong place, what do I need to do with the foil? Gotta move it, take it off, so I'm in flip-free position, right? Can I move the foil with my fingers, or do I not need to go get gloves and towels? I can move it with my fingers because as soon as the foil comes away from the grill, how long does it take the foil to cool? Not long. So I'm going to stick to the fingers. As soon as that foil is away from the heat, the foil does what? It cools. Okay? The nice thing about things that have a very small specific heat is they cool and heat very quickly. So when I put foil around bread and put it in the oven, I pull it out, pull the foil away, and it's cooled instantly. I pull the foil off the pan, it's cooled instantly. Now I can't grab it or grab the pan will be hot. If I have grease or oil or something on the foil's still going to be hot. But if it's just the foil, as soon as the foil comes away from the hot object, the foil cools instantly. Now, water. Does water work the same way? No. Water cools and heats very slowly. So when you think about heating water at home to cook whatever you're cooking, some rice, some noodles, some spaghetti, whatever, it takes a while for the water to start to heat and boil. The more water you have, the longer it takes. And if you leave it sitting on the stove, it takes a long time to cool down. When you think about our science, you talked about hurricane season, When did hurricane season start? I guess it is the end of spring, because summer doesn't really start at the end of June. It starts at the beginning of June, and it goes through when? Goes to the end of November, okay? And that's because water stays warm enough to support hurricanes all the way through the end of November. Those of you who go to the beach in the fall, can you walk and get in the water in October? You could. Water's warm enough. However, the air temperature is cold. When you get out of the water, how do you feel? You feel cold. It means you're going to the beach over spring break or in March or April. Yeah, it's cold. Really cold. Water does not heat up just because the air temperature has got warmer. The water temperature takes a long time to warm up. A lot of people don't like to go to the beach even early in the summer, like what we would consider early June, because the ocean water is really not that wet yet. It's not that warm yet because it hasn't had all summer to warm it. Those people who like to swim in the ocean prefer July or even August because the ocean water is much warmer by that time of year. It takes a long time to get that ocean water warm. That's why hurricane season is much worse in September and October. All that water's had all that time to get warm. Okay? I don't like sharks. All right, so I only get in the pool at the beach. I don't like sand. I grew up with sand. I don't like sand. If y'all would astroturf the ocean, I'd be fine with the ocean. Oh, homework. Before I forget, let's talk homework. Homework answers. I don't feel like we should check it. All right, let's do the heat homework first, and then we'll do the properties. The homework with the math first, and then we'll do the properties. All right, so the math homework first. Number one, you could either have written 10,460 would be the calculated answer. So now we need to round it to one significant digit, right? So 1 times 10 to the 4th, or 10,000. All right, number two, somewhere around 0.598 would be the answer. You need two significant digits, so either 0.59 or 0.60 joules over grams degrees Celsius. Number three, you need two significant digits here. I got 20.7, so I rounded to 21 joules. And the last one, I got 0.136. You need three significant digits, so I left it alone. Joules over grams degrees Celsius. Questions about any of those four? Okay. Now, for the one that says properties, let me go find a blank. It'll be easier than me hunting for mine. All right. Blue color. What'd you say? Physical is correct. Density. Good. Flammability. Chemical is correct. Solubility. That is physical. Solubility is the ability to dissolve. It doesn't necessarily have to be in water. We will talk a lot about water because that's what the state wants us to focus on this course, but it doesn't have to be in water. All right, reacts with acid to form hydrogen. That's chemical. Supports combustion. Chemical. Sour taste. That's physical. Some things just naturally have a sweet taste, a sour taste. You just don't like the taste, but it's a physical property. Melting point. That's physical. Reacts with water to form a gas. That's it. That's chemical. Anything that says reacts is chemical. Reacts with base to form water. Hardness. That's physical. You might have talked about the Mohs scale and the earth science and the hardness of rock. We're going to talk about the hardness of metal. That's the physical property. Boiling point. Physical. Can neutralize the base. Chemical. Luster. That's physical. Remember what luster stands for? Shininess. Some things are generally shiny in chemistry class, and some things are not. And the last is odor. That's physical. Some things have a really bad odor, and some things do not. All right. So yesterday, we were talking about physical change when we got stuck at the end of class. All right. The end of class, we were talking about physical change. Now, we said yesterday that we will not okay, will not make a new compound. And CMPD is the way I will abbreviate compound all year. All right. Now, we talked about some things that you could do that are physical. And you don't have to write this all down again. You got it in your notes from yesterday. So, the things we wrote down were like tear, grind, maybe shred. You guys have all seen shredders shred some paper. Maybe you shred or cut up or grind some things at home. Cut, okay? Any of those things would not alter the properties or the compound significantly, okay? You would all be able to put it back together and have the exact same material you started with. Now, then we switched over and we started talking about phase changes. And we wrote down some words. And I always sort of assume that people know what those words mean. And I probably shouldn't. Given that Abby, y'all tell me you have a sub in middle school, so let's run back through those and make sure everybody's on the same page that I'm on. So give me one of the phase changes you gave me yesterday. All right, and you're freezing. All right, tell me what that change involves. We go from a what to a what? Okay. We start from a liquid and we go to a solid. All right, I heard boiling out there. Boiling is a pretty complex animal, and I'm not going to talk a lot about it today. But there's a lot more to this than just saying that it changes from a what to a what. Okay? Because we have to talk about equilibrium and equilibrium vapor pressure, and there are conditions under which a liquid can boil, and it doesn't just change from a liquid to a gas. Because what other state change occurs that changes directly from a liquid to a gas? I thought I heard it out there. Evaporation. Evaporation changes from a liquid to a gas. So what's the difference between a liquid and a gas? Are those the same thing to boil and evaporate? No, they're vastly different, and there's a whole set of reasons why they're different and conditions under which we boil and under which we evaporate. Evaporation is a non-boiling liquid, okay? But if you went home and put a pan of water on the stove to make noodles, and let's just say you were my son who's 12, and you decided, I love this one. He went home and made dinner for us one night, made tacos, the only meal he likes. Made tacos, and in the middle of it, he decided to go take a shower. Came back, and the meat had burned on the stove. And then he said, oops, my bad, I needed a shower bomb. Really? In the middle of dinner preparation, you decided you had to have a shower? Couldn't have waited until after you finished? Okay? Now, but let's just say he was making spaghetti. And he decided to put the water on the stove and went and took a shower. When he came back, what would have happened to all the water? Would have been gone. Now, if you told me that it evaporated, would I have known what you were talking about? Yes, but did it technically evaporate if it was boiling? No. Are you struggling over there today? What is wrong with you? Oh, okay, it's the whole sliding out of your desk thing. It's a little distracting. Try to sit still. All right, so what other phase changes did we talk about yesterday? Condensation would be what? Gas to liquid. All right, what else? Sublimation. What would sublimation be? It's what? Solid to a gas. Okay, I think the only one we don't have up here was the opposite of freezing, which is melting. Melting goes from what to what? Solid to liquid. Okay, does everybody remember what those are from middle school? We will do a lot with those later in the semester. You'll have to be able to calculate the amount of energy during the change, read them off a graph, be able to tell me if they're endo or exothermic, lots of different stuff. But those are just basics. I sort of assume everybody knows. We do know those, right? Even if you had a crappy experience. Okay. Now, these would all be phase changes. They're all physical. They don't change and make a new compound. So even when water, which can exist in plain old liquid form, like you guys get out of the water fountain, it happens, you probably have it in a bottle somewhere in your book bag, and it changes into an ice cube, okay? It's not a chemical change. It's still plain old water. But when I tell people that, or I ask it on a test, they just look at me like, huh? So, how are we going to be able to decide? So yesterday, I said, no problem. We're going to talk about some indicators. So what am I talking about? All right. So what's a chemical change? Okay. So this will alter the identity, first of all. So it can't go back, like Zoe said. Not going back to what it started at. We will get a new material with all new properties. And I always use the same example because it's one students can relate to. Now, tell me what NaCl is. Okay? Plain old table salt. Tell me what you know about it. What does it look like? Okay? White. Crystal. Broken up crystal. Okay? Is it safe to eat? Okay? Safe to eat. Now, I'm not saying you can eat a salt shaker every day for 25 years and not wind up with some heart issues, but you can go sprinkle it on your food today and it's fine. Now, how does that compare to what it starts at? All right, sodium is a silver metal that explodes in water. Now, what is our saliva predominantly made of? Water. So if we ate a sliver of sodium, what would happen? I have water. Okay? So we can keep sodium metal. Okay? That's got to be a little rough on it. It's soft, but still, it is a metal, and it would explode, and our head would blow off. Chlorine is a yellow, poisonous gas. Take a couple, and you're dead. Okay? Nothing more than and this. Okay? Pretty much. All right, they don't do that. Now, silver metal explodes in water. Yellow poisonous gas. I think most of you can see when you use the table salt that you have at dinner when you go home tonight that it does not have any of the properties that sodium metal and chlorine gas originally have. Okay? So when these two things interact chemically, it gets all new properties. It doesn't keep anything it starts with. Whereas when we talk about a physical property, it keeps almost all of its properties. It might change the state, but it doesn't lose anything other than the state. It keeps all of its properties. Sort of like, if y'all ever had vegetable soup? Yes, no? Okay, you don't like it. All right, you've seen vegetable soup though, right? You've never seen vegetable soup? Yeah. Okay, pretend you've seen vegetable soup. You know what a potato and a carrot and a piece of corn look like, right? When it gets mixed together in the soup, in water, with tomato-based maybe. Okay? Does the carrot still look like a carrot? Does the carrot still taste like a carrot? That's a chemical change or a physical change? It's a physical change. That carrot still looks like a carrot. It still tastes like a carrot. It does not get new properties. That sodium is silver. It explodes in water. Does it have new properties over here? Yes. It's not a physical change if that happens. This is a chemical change. So, how can we tell the difference? I told you yesterday, you're going to learn 5 indicators. Now, do you have to have all 5 to be a chemical change? No. How many do you have to have? 1. Now, you're going to see all 5 in the lab. Did you hear me say that? Yes. Okay. You're going to come up and ask me. Is this in the lab today, Ms. Paul? Number 1, production of light. Now, this reaction right here produces light. When sodium and chlorine gas come together, you get a big burst of white light when you make salt. Okay? So that's the indicator you get when that forms. No. Well, I take it back. Yes, but not that way. That's pretty dramatic. We're going to do a different way. And you cannot eat the salt because you could have unreacted hydrochloric acid, and we don't need anybody dropping dead to do that either. No, that's just going to wet you. I mean, you can eat it. I don't care. If you wind up poisoned, that's your own problem. I'm going to do my part. I'm going to do my part. I'm going to tell you not to eat it. If you eat it afterwards, that's on you.
What if he gets to
Huh?
What if he gets to die?
Then he did not wear his safety equipment, and there's a lovely eye wash fountain back there. All right, the production of a gas. How are you going to know you made a gas today? Nope, a lot of gases have no odor. They're also clear. How you going to know? You're going to use a scale to find the maximum object, but not the gas. You could test the gas. That'd be one way. Put a baby in a bathtub. How do you know it has gas? Yep. All right, unexpected color change. Now, I have to qualify color change because if you go to the store and buy grape Kool-Aid and put it in water and it turns purple, that is not a chemical change, people. That is food color. Yeah. You go buy some red food color and you make pink icing on a cake. That is not a chemical change. However, if you mix a clear, watery-looking substance and a clear, watery-looking substance, and it turns bright pink on its own, that is an unexpected color change. That is a chemical change. You mix a light pink and a clear, and it turns neon green, that is a chemical change. Okay? Huh? That is chemiluminescence. Okay? So that would be a chemical change. That would be an indicator of something chemical going on. All right. Now, if you had something on the color wheel in art class, for example, let's say we took a red and a blue. What happens if you mix a red and a blue? You get purple. Now, if that happens, and you get something expected from art class, that's not a color change either. But if you mix a red and a blue and it's supposed to be purple, and it turns bright pink, that's a chemical change. Now, one of the ones that people have trouble with on an exam is like the leaves outside. And they go, oh, that hasn't been in years. That's not what expected. You know the leaves are going to change. What happens that you learned about in biology class with the leaves. Yes, and their colors change. That's a chemical change. That's a chemical process the leaves undergo every year. The leaves just don't up and say, oh, I believe I'm going to change colors today. Okay? That's a chemical process. Now, number 4 is the one I've been telling you about. The formation of a precipitate. Now, a precipitate is a solid formed from 2 liquids. Okay? Not rain, sleet, snow, or some other kind of fair weather friend. It is a solid. So if you mix 2 liquids today and it forms a solid, that's a precipitate. But if it doesn't form a solid, it's not a precipitate. And number 5 is a change in temperature. Now, when I say change in temperature, I don't mean we heated it on the stove or put it in a microwave or stuck it under a Bunsen burner. Okay? You mix 2 things, mix them together, and the temperature changes because of that. Now, there's 2 kinds of mixing that can take place. We can have endothermic. Anybody remember the other word that goes with it? Endothermic is what I gave you. Exothermic. All right, you remember what they mean? Okay, outside and, okay, so endothermic means heat is absorbed. And exo means heat is released. Okay, one of these is going to feel hot or warm today. One's going to feel cold. Endothermic will feel cool or cold to the touch. Now, that means exothermic will feel hot or warm to the touch. Now, the only way you're going to be able to know this is to take the test tube or the baggie and actually feel it with your hand. Okay, nothing I'm giving you is going to burn you or cause any kind of issues during the lab. But you do have to put the Ziploc baggie or the test tube in your hand to actually feel it to know if it's going to be endo or exothermic. Okay? You don't do that when you get to the questions. You're like, dang, how can we? You have to actually feel it. Any questions about that? Okay. All right. Practice for just a second. So what now? Yeah. So who's going to start out? All right. Now, we're going to do 2 things. One, we're going to decide if the changes in these are chemical or physical. And 2, if they're chemical, we're going to decide which indicator they have. So, if we look at question 1, it says sodium dissolved in water. Is that chemical or physical? Sorry, what? Dissolved? All right. Does it produce light when something dissolves? No. Does it have a temperature change? No. Does it form a precipitate? Does it change, produce gas? No. And does it have an unexpected color change? No. So it's what? It's physical. All right, number 2. Hydrochloric acid reacts with potassium hydroxide to produce salt water and heat. That's chemical. Now, what is the indicator out of those five that you see described in question number 2? Heat. So which indicator is that up there? Just right, change in temperature. So write chemical or C, and it will change in temperature. Okay? I want you to do that for all 17. The physical, just write physical, because there is no indicator. Are we done? All right. Second one. Sodium hydroxide dissolved in water and 2 is already done. Number 3. How much sodium replacement two? That's physical. All right. Number 4. Water keeping in change state. That's physical. It's a state change. Number 5. Potassium chloride decomposes to potassium chloride and oxygen gas. That's chemical. What's the indicator then? Reduction of gas. Iron rust. Chemical. What's the indicator? Color change. When you rust, it changes color. Alright, when placed in water, sodium pellet catches on fire, if hydrogen gas is liberated and sodium hydroxide forms. Alright, why? Alright, gas and light. You got a gas, which is stated in the question. If you catch on fire, you produce light, and there's one more I'll take. I would take color. It wasn't what I was looking for. Change in temperature is what I wanted. State is not one of the indicators, and it doesn't make a specific state. Specific is liquid, and you make a solid. There's nothing stated there about liquid. All right, evaporation, that is physical. Ice melting, physical. There's the best state case. Milk souring, if you've never seen, would be very difficult for y'all. It's coming. It changes in color. Where's yellow? Also curdles and makes a great cooking sauce. Yeah, it does. It does with the cheese. Sugar dissolved in water. Physical. Wood rocket. Yep, it's gonna be why there's a couple you can use here. Color. It's not too liquid. Remember, to be a precipitate, you have to start as a liquid and turn into a solid. You can go color, two more. Temperature change, and gas. Alright? Now, pancakes cooking on a grill, if you've never seen, you're going to struggle with it. It is chemical. Always temperature because it's on a grill. So what? It will change color. And there's one more. This is why I said you have to see it. Remember, it's got to start as a liquid. It's not really starting as a liquid. What? Anybody tell me why? Not because they rise. What do you see happening when the pancakes are cooking? The bubbles. All those little holes in the bubble being released in the pancake. Okay? And if you think about it, anybody lazy like me, and by the time you got to order and shake the container, what happens in the container? It expands when you get all that gas. When you take the top, when you open it, when you hear it. All that carbon dioxide gas is released. Okay? And that's what happens with the little bubbles. It's all the gas is released. Breath growing it along. What? All right, I hear physical, I hear chemical. The biology teachers will be so disappointed that half of y'all say physical. All right, it's chemical. Now tell me why. What are the processes going in biology class? Very good. So what two answers could you give that I'd be happy with? That's light. I might be able to live with that because that's what we're looking for. Light and gas. So that's a state of gas and it is light. All right, the tires are played with air. Physical. Food is digested in the stomach. All right, there's at least three you can give you here. Direction of the gas. We don't mix two liquids to make a solid. Unexpected color change, necessary colors from beginning to end. We have gas, color change, change temperature. It does not go through and not change temperature. And water is absorbed by paper towel. Physical. All right, everybody got it? All right. Now, when you come to me to get your or turn in your lab sheet, you need to pick up your two sheet. Now, I don't require that review sheet get turned in. Now you have to work on it to the bell, and I'll be glad to answer questions. But the way that I do review sheets, because I will not be going over review sheets on Monday before the test. The answers are posted where? On the website. Right? So, if you wish to study this weekend, the answers will be available to you. You choose after you leave at 1:20, not before. So if you finish the lab at 1 o'clock, then you have 20 minutes to study. I sincerely doubt y'all be done at 1 o'clock, but most of you will finish before 1:20. All right, so you'll have time to get started on the review after I give you the conversation. Well, if you leave here at 1:20, you decide to do that. That's fine. I will tell you, on the review sheet, I strongly recommend you look at the math problems 7 to 11. You will see some of those on the set. Okay? So the answer key will be posted on the website for today's date. So if you want to check them out, I'll need to do that. Now, you will need eyewear or goggles and paper. I got to unlock the goggles because I just sterilized those first class from Thanksgiving. Be thankful because they're remodeled. That's what the cabinet is. Because before, 2 years ago when they remodeled, all this was matching. Joey, goggles, everybody was born. 5, 6 years prior. So, that replacement in 5 or 6 years. And you have no way to wash and sterilize it for every couple of years after you most of the time. So, the fact that you have the capability to do that. So, if are hanging in the cut, goggles are on your eye. Pretty soon people are going to yell at like I just said to you. And that one thing in their hands, that you look to their face, and kind of holding their goggles away on the countertop, okay? I'm moving the spot that you said. You can't wear that. You can't wear what? There. Goggles over the right. All goggles are designed to go over the right. Okay? The reason for that is one of the things I like my house. I don't want to pay on my house, but I do on my house. I don't wish to be fired. So I'm a little bit of a range of the idea. I actually come to this place from something good. Okay? I hate to do that, but I do it. So, the goggles are required. The papers, not so much. They're just, needed and one part. Okay? The scale, you need it, and the pen. Just one off, left it out. Somebody do it. Not put it back yourself. On the left, yourself. We're just measurement or observation. I thought this was like this word. It's actually fine. Find the volume of the piece of phone. This is a flat. First of all, there's 6 factors because there are 6. Okay? So when you go to a counter, there's a group on each side. Somebody's got the basket. Make sure you notice that the person notice on the counter is not your basket. And you don't take 2 because there's one counter. Basket has nothing to do. So, get your styrofoam piece, those are because on the styrofoam. Find the volume, watch the volume down, correct, get the digits, the beginning. Then move on to color, write its color next. Right? Find the actual things I'm asking for. And tell me this is for chemical. Tell me this is for extra. Once everybody is situated in the room, I will demonstrate. Number 1, this is magnesium. I'll walk around and take the gas off and make it roll oxygen before I turn the gas on. And then when you get to step 2, you're going to have to take step 2 and add lead and potassium iodide. Okay, when you do that, make sure everybody does it right. Hold the dropper way above here so you don't contaminate my chemicals. Don't stick it way down here in step 2. Hold it up here, add your drop. Hold it up here, add your drop. The reaction takes place. If you stick the stopper down in here, then you stick the next one down in here and it bumps the side, you're contaminating the drop. So hold them up here and they don't touch. Okay? Swirl it and let it mix, and then make your observation. When you're done, this has a lead compound in it. You try not to put it all down the drain and you're going like that. Okay? All back in here. And then when you're done, you just plug the speaker back in. I'm open to help you. Don't do that, buddy. Alright? Test it, you put it back in the bucket. I'll take care of it at the end of the day or something. Now, bags are for step 3. Have lovely speakers that are not dry anymore. Put some vinegar in it. Take this, put it down in the bag, open it, put it down in there, all the air out, all the air is out, push out of there, close the bag. Once that's done, then you can turn it over. Don't turn it over until it's closed and all the air is out. You make a mess and turn it over before the bag is closed, you're cleaning it up, not me. Okay? Once it's done, you shelf it, put the bag up, take this out, rinse it off, put that back, this is trash, or the trash bag. I cannot use it again. Okay? Put this way, $3 or $100, I'm not washing out that. Okay? Not that cheap. Okay. Any questions? Ready? We have 18 people. This is it. Just grab their keys and open the cabinet for the dog. This one should be easier. Let's do better. Be specific in your answer. Don't assume I know things. You're here to get. Yeah, where what? Why? What, too low? That's what the goggles. Goggles are required.
I'm trying to look cute. Well, if you want to look 16, you're welcome.
I know, let's try to be nice. I know it's a struggle, but try.
I know.
If I agree.
Are we doing? Are we finding this? Wait, this one. Are we finding this?